Greetings! Welcome to LDI 1.1 Fair Die. It shows up on page 6 of your textbook. In a famous die experiment, out of 315,672 rolls, a total of 106,656 resulted in a 5 or a 6. If the die is fair, the true proportions of 5 and 6s should be 1/3. So you ought to take your calculator out and see if that comes out close to 1/3, okay? However, a close examination of a real die reveals that the pips are made by small indentations into the face of the die. Sides 5 and 6 have more indentations than the other faces, and so these sides should be slightly lighter than the other faces, which suggests that the true proportion of 5 or 6s may be a bit higher than the fair value of 1/3. So let's see what they're talking about there. Let's go and take a look at this picture of a stack of dice. If you take a look at this side here, the side with the 6 pips cut into it, you'll see that there's more material removed from that face than the face that has only 1 pip removed from it. Now if you go get a real die and you take a look at it, you'll notice that the 1 is on the bottom or underneath or straight across from the side with the 6. So this side, the side with just 1 pip, is going to be heavier than the side with 6 pips. So it would reason that since this side is heavier, it would land down more often and the 6 would land up more often. Same song, second verse, goes on here with the 2 and the 5. The 5 and the 2 are opposite of each other on a die. More material removed from here, less from there. This side's heavier, okay? So the researcher's hypothesis is that the fair value is going to be a bit higher than 1/3, okay? So to answer their question here that they're asking us, which is state the appropriate null and alternate hypotheses for assessing if the data provide compelling evidence for the competing theory. In the case of the null, it's the status quo. It's what we think would be true if it really was a fair die. So the indentations have no effect, and the proportion of 5 or 6s is as stated, which is going to be 1/3. Okay? Now, the researcher, which is the hypothesis that we just discussed about the weight of the sides of the die, the researcher infers that, oh, no, that's not the way it is here. That's not the way of the world. The die is not fair, and the indentations have an effect. And the proportion of 5 or 6s is what? Well, it's greater than 1/3. Okay? Oh, not 1/5, 1/3. There we go. Okay, so let's talk just a wee bit more here about what we mean by the null and the alternate here in this particular case. If we were to just state the null and the alternate in English and not include the proportions of 1/3 in it, then we would say something along the lines that the null, the status quo, is there is no difference between the 5 and the 6s when compared to the other sides of the die with respect to how many times those faces come up. The alternate hypothesis, which is most commonly referred to as the researcher's hypothesis, would be that the 5 and the 6 come up more often. Now notice that's how we would state it in just plain English, and that's a good idea that you always do that first before you go trying to figure out how to state it numerically or in some sort of symbolic fashion, okay? All right, well, hopefully that helps get going in the class, and we'll see you all back here soon for LDI 1.2.